So, good day everyone. I am Mr. Feliciano, your instructor for Lecture 6 entitled Thermochemistry. Just a heads up, our topic will contain 3 videos only. The first video will be thermochemical equation, the second video will be the laws of thermodynamics, and the third video will be the heats of reaction. On each video, I will teach you the concepts and also how to solve problems related to those concepts. So let's start with thermochemical equations. So first, these are chemical equations that are very similar or just the same as the stoichiometric equations that we tackled on lecture 3 and lecture 4. But on the other hand, these thermochemical equations contain another quantity or rather information about the reaction, and that is the standard enthalpy of reaction, and it is denoted by these symbols: delta H degree sub Rxn, or we can just call it by its name, standard enthalpy of reaction, or sometimes called as the molar enthalpy of the reaction. So as you can see, just the same as the stoichiometric equations that you used, there are parts. So A, B, C, and D, which are not capitalized, are the coefficients. Capital A, B, C, and D are the substances. The subscript of parentheses with S, L, G, AQ, or other words are the phases. What do I mean by other words? There are times, such as carbon, has different phases, or rather has one phase, but in different structures. For example, carbon as graphite is very different from carbon as diamond, and is very different from carbon as a nano scale. And um, also, as you can see, we have the standard enthalpy of reaction, and also there are differences in the irreversible and reversible reactions. For the irreversible, it only has one arrowhead pointing to the right. In reversible reactions, it has two arrowheads on both directions. So just a reminder, in dealing with thermochemical equations, just like the coefficients, when doing arithmetic of the enthalpy of reaction must be multiplied, divided, subtracted, or added also. So let's go back. So let's say this is one equation and this is another equation. When we add these two, we should also add these two. When we multiply everything by 2, we multiply also this by 2. When divided by 2, divide also by 2, and so on. If the chemical equation is reversed, multiply the enthalpy of reaction by -1. For example, in this irreversible reaction, let's say this is reverse. So C plus D yields A plus B, then this will be negative if this is positive in the forward reaction, and vice versa. So let's try a sample problem including thermochemical equations. Given this thermochemical equation, let us find the heat evolved when we use 74.6 grams of sulfur dioxide with a molar mass of 64.07 grams per mole and is converted to sulfur trioxide. So simply we will just multiply it by its conversion factors given by this. First is the molar mass, so that we can convert the grams into moles. And then since we have this information, we can convert the moles into energy or kilojoules of energy. So first, multiply it by its molar mass to cancel out the grams. And then multiply it again by its standard enthalpy of the reaction in terms of kilojoules per mole, so that we can cancel out the moles. And so we will have the final answer as negative 115 kilojoules. And Take note that if the magnitude is negative, then it is releasing energy or exothermic. If it is in positive magnitude, then it is absorbing energy or endothermic. So you may now watch the second video.